All right, we got our last video here of chapter 7. In 7.6, we were working with common logs, and common logs have a base of 10. They pop up. We talked about like Richter scale and measuring sound in decibels and things like that. The last thing that we're going to do is log base E. We call E the natural log, and E actually is a number. So I'm going to write down here for you. It's one of those crazy irrational numbers. It's like pi. You know, every time you see pi, you know it's about 3.14, 159, etc. E is a number that is approximately equal to 2.71828, etc. And it just goes on forever. It's irrational. It just repeats forever and ever and ever. And E is this base that pops up all the time. E shows up whenever something grows exponentially and continuously. So things like population growth or radioactive decay or financial interest, those interest problems that we were doing. We're going to see some of those. So that base is used in very important real life applications. So let me show you really quickly. We've got growth as well as decay that can happen from this exponential function. So when we have e to the x, that is, we're going to have growth. So y equals e to the x would look something like this. It's going to grow like that. And so we've got the 3 points that we're used to seeing. We've got the point 0, 1. We've got the point 1e, and then we would also have the point -1, 1 over e. So the same 3 exponential points that we're used to having. And then we have a second function, which we call y equals the natural log of x. Okay, so this is a logarithmic function that shares the same base, and it would look like that. Okay, so I'm going to define that for us really quickly. So y equals the natural log of x. This is just the notation that we use to write log base e. So whenever we have a log function and it's got a base of e, these two things are exactly the same. Okay, so log base e, we write it as ln. The reason it's ln instead of nl is because it came from the French term for this, it's like natural log. In French, it's like logarithme naturel, or like if I spoke French, I could say that better, but that's why it's ln instead of the other way around. So whenever you see this, it's just log base e. You can write that if you're more comfortable with it. We also have decay. So if we saw exponential decay, our exponential function would look something like this. Okay, so that is taking e and raising it to a negative x power, so flipping that to be exponential decay. And then same thing with our natural log. Our natural log function would go like this. Okay, so that one would be the reverse, the negative natural log function. So you don't need to know exactly what these look like. You just need to know that we've got an exponential base e and then we have a logarithmic base e. They're inverses of each other, just like most log and exponentials are inverses of each other. So all the stuff that we're going to be doing on these notes are things that you've seen before. We just saw them with different bases. So we're doing tons of the same stuff from this whole chapter so far. We're just going to be doing it with base e. So the first thing we're going to be doing is translating back and forth between log form and exponential form. So if you remember, when we write into log form, we write log, and then next comes the base. The base is e. And then comes 23 equals what we have up here is the power, which is x. So again, just translating back and forth between that log and exponential form. It's really weird to see log base e. You're always going to see natural log instead. So this is the same as natural log of 23 is equal to x. We're not solving anything. We just want to get this into logarithmic form. So we can do the same thing here. Log, the base is e. Next comes the x equals 4. Same thing, we very rarely see log base e, so we're going to write it as natural log of x is equal to 4. Not solving anything, just rewriting. Same thing with example 2. So this, remember, this technically means log base e of x, and this means log base e of 25. Seeing it like that will help us to write it in exponential form. So in exponential form, we have base e raised to the 1.2528 power is equal to x. Okay, not solving, just putting it into exponential form. And same thing here. We start with our base e, raise it to a power of x, and set it equal to 25. So you should have had plenty of practice with this before. You're just converting back and forth between that log form and exponential form. So just to get you a little practice with those, that's the first type you'll see. And then we'll be doing some properties. It's the same properties that we did in 7.5. So if we take a look at this one of the first properties we had tells us that if we have a number out front like this, one of our properties says you can bring it on the inside as an exponent. So I'm going to do that first. So just with this first term, I'm going to bring that 4 inside as an exponent. That's my third property of logs. And then I'm not touching the second one yet. So I'm going to actually simplify that up. Write 3 to the 4th as 81 plus the natural log of 6. And then property number 1 tells me if I have 2 separate logs and they are being added together, what I do is I write it just as a single log and I multiply these numbers on the inside. So 81 times 6. So I'm going to multiply those together. So I will have 486. And that is just one single log function because that's our end goal. So we combined property number 3 with property number 1 and just wrote it as one natural log expression. All right, same thing here. This one I'm going to start with the exact same property I started with before. This second power can come up, or I'm sorry, the second coefficient can come up as a power. So I'm going to first write this as natural log of 3 squared. That's property number 3. Tells me the 2 can jump in there like that. Plus the natural log of 4 minus the natural log of y. So let's start and just do them 2 at a time. So let's start with this one. So that first property that I did right here says that I can multiply these 2 things together and put it inside one log function. So I can multiply 3 squared, which is 9, times 4, and then minus the natural log of y. So I'm going to simplify inside here. So 3 squared is 9, times 4 would give me 36. I'm sorry, 36. So I'm going to multiply those together. So I've got the natural log of 36 minus the natural log of y. So now that the first 2 pieces are simplified together, I can take these 2, and now I'm using property number 2. When I have subtraction like this, the subtraction tells me that when I write it as a single log, there will be a quotient on the inside. So that would be your final answer for something like that. Okay, quickly we're going to add on just some special natural logs. So this, remember, is log base e of e. Anytime, we went over this the other day, anytime these 2 match, it is always just equal to 1. So if you see natural log of e, it's just equal to 1. All right, this one, natural log of 1. Remember, that's the same as log base e of 1. We talked about this a while back. If this is 1, remember what the log function is it's what power of e would give me 1. And the only way to get 1 is if you have a power of 0. So again, if you ever see natural log of 1, just know that it's 0. And then this, if I have e to some power, this means, again, log base e of e to the a. This one is saying e to what power gives me e to the a, so that would, of course, just be a. Let me show you kind of a little trick. The same property that I used up here to put my exponent from being out front to being on the inside, I can reverse that. And so that a will come out front as a coefficient. And now remember, this is just equal to 1. So this is just a times 1, which is a. So anytime you say natural log of e to some power a, the answer is just going to be that value of a. So those 3 you should have memorized. We're going to start to work with those. Let's flip and solve some equations. Okay, so equations and inequalities. So we've got your base e, your natural log. So we're going to go through the same sort of steps that you guys did while you were solving some of your other equations in like 7-4. But this time, of course, we're going to be dealing with natural log stuff. So with these ones, what you want to do first is you need to get the exponential piece by itself. Okay, so big tip for you is you need to isolate the e to the x part. So we're going to do whatever we have to. So like this one, we're going to start by subtracting 4. So this will cancel. I'll have 3e to the negative 2x equals 6. It's still not quite isolated, so my next move would be to divide by 3. These will cancel. So now I have this exponential piece by itself, and 6 divided by 3 is 2. So my move, once I isolate the e to the x, let's say that's step 1. Step 2 would be to convert the form. So this step works for both of these. Convert the form means if you're in exponential and you don't know x, put it in logarithmic. If you're in logarithmic and you don't know x, put it in exponential. So with this, I'm going to write it as log base e of 2 is equal to negative 2x. So that's just my classic conversion back and forth between log and exponential. So this, remember, is natural log of 2. We have a button on your calculator for that. I'm going to show it to you in just a minute. Equals negative 2x. And so now the last thing that you would be doing is dividing both sides by negative 2. Okay, so these would cancel. So once we know what this is, we'll know what x is. So let me show you how to plug that all in on your calculator. So the natural log button is right here. You've got e to the x. You just have to hit the blue key first to get your natural log. So we want the natural log of 2, and then we want to divide that by negative 2. So that would be this. We want 4 decimal places. So we're going to have x equals negative 0.346, and then the last digit would round up to a 6. Okay, so that would be your final answer. Next one, really similar. We're going to start by isolating that exponential piece. So subtract 8 from both sides. 17 minus 8 is 9. Divide both sides by 4 to get this completely by itself. And I can just leave it as 9/4. You can do a decimal if you want, but it doesn't really matter. So since we're in exponential form and we don't know what x is, we're going to do the same thing that we just did up above. We're going to convert the form, put it into logarithmic form. So log base e of 9/4 equals negative x. So we never see it like this. We're going to write it as natural log. And so the only thing we need to do to get the x by itself is to multiply both sides by a negative 1. So when I multiply this by a negative 1, it changes to positive. So I need to multiply this by a negative 1. So I'm going to plug this in. So put the negative first and then hit Control before e to the x, and I can put 9/4 right on the inside. Same thing, we want 4 decimal places, so negative 0.8109. Okay, so that would be your answer there. And you can always plug these in, and there are of course going to be approximations, but we could plug this in, for instance. If I plugged in 4 e to the negative, I have a negative in here, and my answer is a negative, 0.8109, and then plus 8. I should get just about 17. It's not going to be perfect because this is an approximation, but you can see it's super, super close. So you can check your answers that way. Next, we've got some log things. So this says just like you can use log to find anything in this form, you can do the exact opposite. So same 2 steps. This time, though, we're going to isolate the natural log function. So start with that. I'm going to divide both sides by 2 to make sure my natural log function is all by itself. So 6 divided by 2 is just 3. So I'm going to convert this into exponential form. So it might make more sense to you to write it like this before you convert it to exponential form. So that rewrite would look like this. E raised to the 3rd power equals 5x. Okay, so before we plug it in, we want to get the x by itself. I'm going to divide both sides by 5. So these would cancel. And then I'm just going to plug this right in. So in my calculator, I can do e to the 3rd divided by 5. And that would be my answer. 4 decimal places, 4.0171. Okay, so final answer on that. And this one we have an inequality. Okay, so I want to put it as log base e first before we do this. Squared greater than 8. Okay, so these are tricky. Remember, you've got to do them in a certain order. So we have to start with this piece. We've got to start with the 3x plus 1 squared greater than, and then convert the rest into exponential form, e to the 8th. Okay, lots of little steps that we have to do before we get the x by itself. First thing we're going to do is square root. Square root. So here I have the 3x plus 1 is greater than. This one's pretty easy actually, because when I square root something to the 8th, remember if I have 8 copies all written out and I square root it, I will just have e to the 4th. I have that little trick where since my index is 2, I can divide the 8 by 2, and that's my new power. Then I would subtract the 1 from both sides. So I have 3x is greater than e to the 4th, whatever that is, and then minus 1. Then to get the x by itself, I would divide both sides by 3. So these 3's would cancel, and I'm just going to plug this beautiful thing into my calculator, and I will show you what I will get. Okay, so I will plug this in. I'm going to hit Control and then the division sign to get a fraction. I'm going to type e to the 4th minus 1, and then over 3. So that's going to give me my decimal approximation. So 17.8661. So I have x is greater than 17.8661. And because this is a greater than, I don't have to worry about my domain restriction. Remember, if it was a less than, you do have a domain restriction. All right, so we've got that, and we're actually going to skip over the compound interest stuff, just in the interest of keeping the time down.